Hello everyone, so today we're going to go over section 7.4 part A, equations and graphs of trigonometric functions. So we have an example here, 2 cosine square x minus 1 is equal to 0, and the question is in degrees, and the interval is from 0 to 360 degrees. Okay, so first we'll solve the question algebraically. We have 2 cosine square x minus 1 is equal to 0. So we can begin by moving 1 to the right-hand side. So we have 2 cosine square x is equal to 1, which of course means that cosine square x is equal to 1/2. And when we take the square root of both sides, we'll get that cosine x is equal to positive or negative 1 over root 2. Which means there are two possibilities. Either cosine x is equal to 1 over root 2, or cosine x is equal to negative 1 over root 2. The first of these two here, the positive version, then cosine x, if we are to solve for x, x could have been in quadrant 1 or quadrant 4. Those quadrants are where cosine x will be positive, and then the other case, quadrants 2 and 3, are where cosine x could be negative. So from there, we can find the reference angle. So in the first case here, the reference angle will be 45 degrees using the 45, 45, 90 triangle. Likewise for the second part, again, the reference angle is 45 degrees there as well, which means there are a total of 4 solutions. The first one will be 45 degrees in quadrant 1, so that's just 45 degrees. The second will be 135, sorry, that's not true. The second will be 315 degrees because it will be in quadrant 4, and the reference angle will be 45 degrees, so it's simply 360 minus 45. Next is the third answer, that's 135 degrees. 180 degrees minus 45 to end up in quadrant number 2. And finally, the fourth answer, this is going to be 225 degrees, 180 degrees plus 45 degrees. Okay, so it says here under solving graphically, the solutions to a trig equation matches the x-intercept of its associated function. So in order to find the solutions here, we simply have to look at y equals to 2 cosine square x minus 1, and then find the x-intercepts. So here we have the function graphed. This right here is 2 cosine square x minus 1 in red. And as we can see, the x-intercepts are 45 degrees. So 45, 0, 135 degrees. So 135, 0, 225 degrees, and not that one, but finally 315 degrees. Okay, so this is set up in Desmos in degrees, so that's why the graph can show us the 4 possible answers. Okay, let's look at example number 2. We'll notice here as well that the emphasis will be on solving algebraically. We use solving graphically as a tool to confirm our answers more than anything else. Example 2. So this one will be in radians. It says here, determine the solution of the trigonometric equation 2 sine square x minus sine x minus 1 equals 0. And then it's for the interval from 0 to 2 pi. Okay, so to simplify things a little bit, we are going to let a equal to sine x. So the equation becomes 2 times a squared minus a minus 1 equals to 0. what this allows us to do is to factor without having to write sine x every time. So we can factor by grouping. So 2a squared minus 2a plus a minus 1. We were looking for two numbers that add up to -1 and have a product of 2 times -1, which is, of course, -2. And then the two numbers that we're looking for are -2 and 1. So that's how we get -2a and plus a. So from there, the first two terms will be grouped together. And the last two terms will be grouped together as well. So here the greatest common factor with the first two terms is 2a, and we're left with a minus 1. And greatest common factor of 1 in the second set of parentheses, which means the two factors are 2a plus 1 and then a minus 1, which will give us 0 on the right-hand side. So what we can now do is to substitute sine x back into the equation. So we have 2 sine x plus 1, and then sine x minus 1 is equal to 0. Again, we're down to two possibilities. Either 2 sine x plus 1 is equal to 0, or sine x minus 1 is equal to 0. So first case will give us sine x is equal to -1/2. And the second case will give us sine x is equal to 1. So from here, once again, we're looking at the quadrants for the answers. So sine x is negative in quadrants 3 and 4. So, and then we find our reference angle using this time the 30, 60, 90 triangle, which will give us a reference angle of pi over 6. So our solutions will be pi over 6 as a reference angle, but in quadrant number 3, so that's pi plus pi over 6 in quadrant 3, which will give us 7 pi over 6. And then the second solution in this part will be in quadrant 4, so 2 pi minus pi over 6, which is 11 pi over 6. On the right-hand side, there's only one possibility, and that is x is equal to pi over 2. So we can think about it as sine theta is related to the y-coordinate in a unit circle. So, and the y value is equal to 1 when the angle is pi over 2. So x is equal to pi over 2 in this case. So in total, we have 3 solutions, and they are 7 pi over 6, 11 pi over 6, and pi over 2. So we can also look at the graph for this one. Here we go. And we can see that the graph is y equals to 2 sine squared x minus 1. This is already drawn in radians. And we can see the solutions are pi over 2, 7 pi over 6, and then 11 pi over 6, which matches what we got algebraically. Okay, so the third question is what happens when we are looking for general solutions to a trigonometric equation, and also when the period is changed. So notice here a couple of things about this question: general solutions, and also this pi over 6, which will change the period. So the period for this particular question is going to be 2 pi over the b value of pi over 6, which will give a period of 12 units. And this will become relevant in just a bit. But for now, let's focus on simplifying the equation. So we can subtract 13 from both sides. 15 minus 13, of course, is 2. And the right-hand side will simplify to just 3 cosine pi over 6 x. And from here, we can divide both sides by 3. So 2 over 3 is equal to cosine pi over 6 x. Okay, so the next step, this is an important part, so just going to use a different color for emphasis. We're going to take the arc cosine of both sides. So we have arc cosine 2 over 3, and then on the right-hand side, we have the arc cosine of cosine pi over 6x. Now, of course, the idea here is that on the right-hand side, the arc cosine and cosine will eliminate each other. And then, so the equation will simplify to just pi over 6x is equal to arc cosine of 2 over 3. Notice here the trig ratio that we're working with, 2 over 3, is positive, which means that the trig ratio that we're looking for is either going to be in quadrant 1 or in quadrant 4. And since 2 over 3 is not a special triangle value, we'll have pi over 6x is equal to just the value of arc cosine 2 over 3, which on the calculator gives us 0.841. Again, that is rounded. And then in quadrant 4, we will have pi over 6x is approximately equal to 2 pi minus the quadrant 1 answer, which of course doubles as the reference angle. For now, so we have 2 pi minus 0.841, which will give us 5.442. So the important piece here is that unlike the previous question, we haven't yet solved for x. We solved for pi over 6 times x by taking the arc cosine on both sides. So here what we need to do still is to figure out what x is, and we're going to do that by multiplying both sides by the reciprocal of pi over 6, which means x is going to be equal to, again, approximately 6 over pi, the reciprocal, multiplied by 0.841, which will give us an approximate value of 1.606. Okay, so that's our first answer. The second answer is going to be very similar. We'll have 6 over pi multiplied by 5.442, and that will give us approximate value of 10.394. Okay, so these are specific solutions in the question. We're looking for the general solution, which means we do have to add the period. And as we found earlier, the period is 12 units. So we're going to add 12n in both parts here, where n is, of course, an integer. Okay, so again, the idea is to start the question by isolating or simplifying the equation so that we have a trig ratio on one side and just a constant on the other. Then we're going to find the value of x by, or in this case, pi over 6x by taking the arc cosine on both sides. And then once we have done that, we'll use the quadrants, in this case 1 and 4, to find out what pi over 6x is. And then we can solve for x, and then we can add the period afterwards. So there's quite a few steps, and it's a rather complex question. So again, let's look at the graph for this one as well. So we can see here, just wanted to highlight a few points for emphasis. So first of all, we do have the solutions that we expected to find, the first one being 1.606, which we found algebraically, and the second one being 10.394. Also, to solve this equation, we let one side, since the left-hand side was equal to 15, so we have y equals 15, and the right-hand side was 3 cosine pi over 6x plus 13, that is in blue. and the intersection would be where solutions will be. So the first one, 1.606, comma 15, and then 10.394, 15 as well. Here we have the graph. The period was 12 spaces, so 0, 16 on the left, 12, 16 on the right. That is one period. And so the next solution that we'll find is simply 1.606 plus 12. And so we get 13.606 as the third answer. And then the next one is going to be 10.394 plus 12, which is 22.394. And we can see that the rest of the solution is going to be the first two, and then and we just add or subtract 12 integer multiples of 12 repeatedly. And that's it. So going back to the notes here, again, we already went over what the steps are, and just talk about the graphical solutions. This is going to be one of those topics that's going to require quite a lot of practice, just to be familiar with the steps that are involved. But in terms of the technique of solving these equations, that is all we have for today. So thank you for listening.